Okay, great. So I'm going to start recording now. And if you have any questions, today will be our review. So this is going to be our review, not for just exam 4, but for the upcoming final. So this is the review. Okay, this is our review. You'll have your exam 4, on Friday. Okay, so exam 4 will be on Friday. All right, so if you guys have any questions, we can go over those. You just tell me, on, for example, the review sheets that I gave you, I can pull those up and I can paste the questions into my PowerPoint. So I'll wait. You guys can just send me questions in the chat. By the way, the chat is here. I'm going to send a message. Question 5 on the review. Which review? Which review? For exam 4. Okay. Let me go to course. Let me download that. So just give me a moment to pull that up for myself. Yeah, number 5. Rewrite the following as a sum with a single sigma beginning at I is equal to 1. Okay, so this is actually a pretty involved question. This question is pretty involved. So let's begin. Okay, so this is the sum from k equals 2 to 8 of 2k cubed minus 6 plus 2 times the sum of k cubed minus 3 plus the sum from k equals 2 to 12 of just 8. Okay, well, oops, I forgot to write the lower and upper limits of this summation. Very good. I trust that that my substitutes went over some of the rules corresponding to sigma notation, but let me just review some simple facts. Let's say that I wanted to take this sum. This will be the sum of k squared from I equals 1 to 4 plus the sum of k squared from I equals 5 to 7. Well, I can just put those together. I can say that's just the sum from I equals 1 to 7 of k squared. Okay. I hope that's clear as to why that is. If not, you can ask me a question in the chat. I'll try to explain, or you can unmute yourself and you can ask me. But okay, so I'm going to do some manipulations regarding this middle term to make it look more like the term over here, right? So I see this k equals 9 to 12, and I see that this is from k equals 2 to 12, and I think, okay, I probably want to combine these two. But this term looks very different than this term, but actually they're the same because of this 2 here. So what I'm going to do is, since this is a sum, I can actually distribute this into here. This becomes the sum from k equals 9 to 12 of 2k cubed minus 6. Oh, and look, these two are now the same term, just with different limits. Okay, great. By the way, if you're watching this on YouTube after the fact, you should probably watch this at 2 times speed, or at least 1.5 speed. Okay, very good. So this term in green became this term here. Good. Now I'm going to combine these two into one term. So this becomes the sum from k equals 2 to 12 of 2k cubed minus 6 plus the sum from k equals 2 to 12 of 8. Okay. Now, since these two have the same limits, I can combine them. And then this becomes, I just want to make sure that I got this right here. Yeah. And then this becomes the sum from k equals 2 to 12 of 2k cubed plus 2. All right, but I want this to start at 1. I want this to start at 1. Okay, so I'm going to replace this. So I'm going to rewrite this here. This is sum from k equals 2 to 12 of 2k cubed plus 2. I want this to start at I equals 1. Okay, I equals 1. Well, then what's my upper limit going to be? Well, let's think. If from 2 to 12 there are 10 terms, that means from 1 to up here there need to be 10 terms. So this is going to be up to 11. Okay. But I can't just write, I'm not allowed to just write this because actually these two would be different. So let me show you that those two are different. So this is, I'll do this one in red here. Oops, I'll do this one in red. And this one I'll do in, just a moment. And this one I'll do in blue. So let me do the red one first. This is 2 times 2 cubed plus 2 plus 2 times 3 cubed plus 2 plus all the way up to 2 times 12 cubed plus 2. Whereas this one, the one on the right, would end up being 2 times 1 cubed plus 2 plus 2 times 2 cubed plus 2 plus all the way up to 2 times 11 cubed plus 2. So these two are different, right? This term is different than this term. This term is different than this term. This last term is definitely different than this last term. Okay, so these two would be different. So how do I make this? How do I make this? How do I make this work? I replace the limits, but now I need to find the correct term. Well, okay, let's think. When k is equal to 2, I is equal to 1. Okay, so I'm gonna make a chart here. This is how I like to do it. When k is equal to 2, I is equal to 1. When k is equal to 3, I is equal to 2. When k is equal to 4, I is equal to 3. And then you can just keep going like this. When k is equal to 12, I is equal to 11. So what's the relationship between k and I? Well, I think it's pretty clear that I, or k, is just I plus 1. Okay, so I'm going to use this fact that k is equal to I plus 1. I hope it's pretty clear because 1 plus 1 is 2. 2 plus 3 is 2 plus 1 is 3. 3 plus 1 is 4. So k is equal to I plus 1. It's always 1 more than I. So now I'm going to use that fact. I'm just going to replace k with I plus 1. Okay, so I use this fact. And now that's the answer. That's the final answer. So I will say that question was pretty involved. It could appear on the final. I don't think it will appear on your upcoming exam, but it could. Okay. Are there any questions about what I went over so far? No, was this clear? You guys understand this? Hmm. All right. Thank you. Sorry. Great. Great. Are there any other questions? So I have the review open from exam 4, but if you have any other questions that you want to go over, I can pull those up. Okay, so while you guys look, I'll just wait. By the way, I want you guys to know, I think pretty much everyone who's going to come to class today is here. I want you guys to know that for some reason Hunter doesn't pay for my Zoom account. My colleagues are paid for, but mine isn't. So I have a 40-minute time limit on my Zoom, meaning that it's going to kick us out within probably 30 minutes, or no, 25 minutes. So I'm gonna upload a new link on Blackboard, and then in 15 minutes we can join that one again. Okay? Will hyperbolas be on the exam? Yeah, they could be. Is the test this Friday? The email you sent says Thursday. By accident, I wrote Thursday. Of course, I meant on Friday. We meet on Friday. It'll be Friday the 13th. Yeah, so hyperbolas can appear in the exam. You have a question about hyperbolas, we can go over it. Can you do question 10? Sure. I'm guessing that you mean on exam 4 review. Yes, okay. Just a moment, let me pull that up here. So find term number 6 in the expansion of 4x plus 3 to the 7. Note term number 1 is 4x to the 7th. Okay, so here um, we're going to use binomial theorem. Okay, we're going to use binomial theorem. Binomial theorem, and you do have to have this memorized, unfortunately. I don't like to have students memorize things, but binomial theorem says that x plus y to the n is the sum from k equals 0 to n of n choose k, x to the n minus k, y to the k, right? And actually, Isaac Newton discovered the binomial theorem when he was discovering calculus. Um, so this theorem can help us to find the expansion of this uh, polynomial. Typically, you'd have to um, expand out the whole thing, but you can employ the power of the binomial theorem to do this question. Well, okay, so let's use binomial theorem here. So 4x plus 3, my y is 3. Here my x is 4x, here my y is 3 in this case. To the 7th, my n is 7. That's going to be the sum from k equals 0 up to 7 of 7 choose k of 4x to the 7 minus k, 3 to the k. Okay, so the first term is when k is equal to 0. Let me explain this. For those of you who watch the lecture on YouTube, you know that we can use what's called Pascal's triangle to find out values of n choose k. And I explained how to generate this triangle before in those videos. So you should be able to make this. Okay, I'm going to keep going for a bit more. I'll make this a little smaller. Am I recording? Yes, I think I am. 15, 20, 15, 6, and 1. Okay. So this is Pascal's triangle, and what it tells you is, let's say I wanted to figure out what is, 5 choose 2. We know that by definition this is 5 factorial all over 5 minus 2 factorial, 2 factorial. Okay, well, I don't necessarily want to do that computation. So what I can do is I can go to this is the 0th row, 1st row, 2nd row, 3rd row, 4th row, 5th row. I can go to the 5th row and look at the second element. This is the 0th element, this is the first element, and this is the second element. So I know instantly that that's just going to be 10. So I go 5 choose 2, and that's going to be 10. Okay, that's what Pascal's triangle tells you. All right, so since I want it says that I want the 6th element. Okay, so the 6th element is going to be when k is equal to 5. Okay, why? Because the first element is when k equals 0, right? I'm starting at 0. The second element will be when k is equal to 1. Third element is when k is equal to 2. And so the 7th element is when, sorry, the 6th element will be when k is equal to 5. Good. So I'm going to plug that in here. I'm going to say that the 7th element is going to be 7 choose 6, 4x to the 7 minus 6 times 3 to the 6. Okay. So 7 choose 6 is, we can find that out, 0, 1, 2, 3, 4, 5, 6, 7. This is 0, 1, 2, 3, 4, 5, 6. Okay, so 7 choose 6 is 7. So this here is going to be 7. 4x to the 7 minus 6 is 4x to the 1. And 3 to the 6, I'm not really going to simplify that because I don't know what it is. But so this is just 28 times 3 to the 6th x. Okay. So I don't know what number that is, but let me write it in the chat. You can plug that into your calculator. You can figure out what the answer is. Okay. And then the way that you would answer this question is you'd say, okay, the coefficient for term number 6 is A. You would say it's the value of 28 times 3 to the 6th. Again, you can just plug into your calculator. It doesn't matter. The variable part is, well, let's see. Oh, the variable part is just x. So I would say that the answer is x. Okay. Are there any questions?
I got a different answer for that question, and I went over in tutoring, and allegedly we had a correct answer,
Okay.
which is the term number 6 is x2, and the coefficient will be 13, 60, 80. So, and it
Let
will
me think.
be,
No, I think that's because your tutor plugged in k equals to 6.
no, I did, yes,
Oh, actually, no, you're
equal
right.
to
You're right.
5,
You're right. You're right. I was wrong. I made the
7 to
mistake
5.
that I'm sorry. I actually made the mistake.
Yeah, it's
So
5.
It should have been 5 here. Thank you. Sorry. Yeah.
Yes.
Yeah. Curses. Thank you for that. That's a good point. Thank
Thank
you.
you. Look,
Good. So this is actually 4x squared. Thank you. Thank you. So this is actually 7 times 16 times 3 to the 5th x squared. I don't know what number this is. Sorry. Thank you very much. Good. So actually, this is the wrong answer. The variable part is x squared, and the coefficient is 7 times
thir
16 times 3 to the 5th. Hmm?
13, it would be 13, 60, 80.
13, 13,
60, 80.
50, 80?
No, 60. 60, 80.
Okay. It's an
There you
interesting
go.
way to represent numbers, but okay, good. Yeah, 136,080.
80.
Thank you. Very good. Yeah. Good. Thank you for catching me. Okay.
For the question prior that one, which is 9, let me double check so I don't give you the wrong
Okay,
number.
we can go over that one in just a moment, but somebody in the chat said after this, can you do the last question on the exam review? So let me go over that one and then we'll go over yours, okay?
Fantastic.
Okay. Okay, so you've got an ellipse. Okay. Um, Let me pull up your reference sheet. Just give me a moment here to pull up your reference sheet. Okay. So on your reference sheet, you're actually going to get this information. I want to show it to you. Okay, so you don't actually have to memorize this. I find it annoying to memorize things, so it's good that you don't have to memorize them. Good. So write the equation of the ellipse in standard form and find the center. Okay, sure. So I need the right-hand side to be equal to 1, and I want to write this in standard form. So first step is I'm going to put all of the x's with the x's and the y's with the y's. And I'm going to leave a bit of space. Okay. So I move this 92 over, and oops, I actually should have left even more space. Just a moment. Okay. So, how can I do this? Well, one thing that you could try is you can divide the whole thing by 4. So you have x squared plus 4x plus blah plus 9y squared plus 72 divided by 4 is 18y. Equals 92 divided by 4 is, let me think, 46, 32. Or is it? Am I going crazy? No, that's wrong. It's 23, I think. Okay. Okay, so now we just complete the square. What should be over here? ideally, what should be over here so I can complete the square?
Two square four,
4. Good. And what should be here?
and that would be
If you
nine
want,
square 81.
you can actually just factor out a 9, and then you can see, okay, what should be here? You'd say, oh, okay, I know, from here you just divide by 1 and you square it. Sorry, you divide by 2 and you square it. You know that should be 1
One.
there. Good. So what happened? First of all, I added 4. Whatever I do on one side of the equation, I have to do on the other. So I added 4 here. So I'm going to add 4 here on the other side. Then it looks like I added 1, right? But really I added 9 because when you distribute this 9 back out, it's as though you added 9. So I'm going to add 9 here. And then what happens? This becomes x plus 2 squared plus 9 times y plus 1 squared equals 23 plus 4 is 27 plus 9 is 36. Yeah, good. And then you can just divide, for the equation of an ellipse, you want the right-hand side to be 1, so you just divide by 36 on both sides. This becomes x plus 2 squared over 36 plus 9 divided by 36 is 4. This is 4. Y plus 1 squared over 4 equals 1. And that will be the final answer. That's how you do that problem. And then I'm going to get rid of this. Or actually, I'll just write it here in red. So the standard form, you would write it here. And the h and the k, well, my h is going to be minus 2, and my k is going to be minus 1. Is that clear? Hold on, let me check out the group chat. Okay. So is that clear? Anyone have any questions on this? By the way, it told me we have 9 minutes left. So like I said, we'll take a little break. I'll send out the other Zoom link with the time that we should all be there. Um, uh, and then we'll continue the class. Okay. Now, sorry, I think you had a question. You wanted to do the one before number 10?
Yes. And my question is more so, the question saying expand the expression using the binomial theorem. My thing is, after we expand the equation, do we need to solve it, or you just want us to leave it like that?
No, I mean, there's nothing to solve. You just have to expand it. So,
Okay, fantastic.
so let me just do this question for you guys. So this is, I know by binomial theorem, let me just write the binomial theorem. I always start off, it might be a good idea for you guys. I've seen this technique employed successfully. You guys just memorize the binomial theorem, and then as soon as you get the exam, you write it down. That's totally fine. So binomial theorem says x plus y, oops, to the n is the sum from k equals 1, sorry, k equals 0 to n of n choose k, x to the n minus k, y to the k. All right. So since I want to do 3x minus y to the fourth, my n is 4. This is my n. My y is minus y, and my x is 3x. Okay, so that's going to be the sum from k equals 0 to 4 of 4 choose k, 3x to the 4 minus k, y to the k, right? Now let me do this out. Let me do it on a different slide here. I'm going to rewrite it. Okay, so I'm just going to go through this summation. That tells me that this is 4 choose 0, 3x to the 4 minus 0, y to the 0, plus 4 choose 1, 3x to the 4 minus 1. And then you just keep going like that. Oops, I forgot the y. Y to the 1.
Negative y.
Yeah, thank you. Negative y. Very good. Sorry, you're on a roll today. Great.
Oh, definitely. I already got so many negative point for that.
Great. Thank you. You guys know that if you make silly mistakes on the exam, I just give you the points. If I see that if your work is clear, if you made a silly error, I just give you the points. 3
That is true.
to the 4 minus 3 minus y to the 3 plus 4 choose 4, 3x to the 4 minus 4 minus y to the 4. Okay, what is this going to be equal to? I'll do I'll do these later. This is 3x to the 4 minus y to the 0 is just 1 plus 4 choose 1 is oh, actually, hold on, let me do it this way. This is 4 choose 0, 3x to the 4. 3x to the 4 is, let's see, 3, 9, 81. X to the 4 plus 4 choose 1. This is a long computation. This is kind of annoying, but you have to do it anyway. I forgot my minus y again. So times minus y plus 4 choose 2, 9x squared, y squared, plus 4 choose 3, 3x times minus y cubed, plus 4 choose 4, y to the 4th. Okay. And now I'm just gonna, how am I gonna get these values here? I could compute them individually, or I can use Pascal's triangle. I think I'll do the latter. So I'll generate, sorry, Pascal's triangle here. Up to the 4th row. Oops. This is 0, this is 1, this is 2, this is 3, and this is 4. So 4 choose 0 is 1. Plus 4 choose 1 is 4. Right? 4 choose 1 is 4. 4 times 27 is, let's see, what is 4 times 27? 108. X cubed, and I'm going to make this into a minus because it's minus y. Plus 4 choose 2 is 6. 6 times 9 is, what is 6 times 9? I can't think today, as you can see. Oh, Chris, is 6 times 9? Am I going crazy?
54.
54, thank you. 4 choose 3 is 4 again. So that's 12. xy cubed, and I'm going to make this into a minus because it's minus y, plus 1 y to the fourth. And that would be the final answer. So like I said, there's really nothing to solve. This is just the answer.
Yes, correct. That what I mean by solving it was like leaving it up to the third row, not solving it like putting it together like that.
No, you
But
have
it
to do
says
that.
span.
Yes.
Okay, thank you.
You have to simplify fully.
Okay.
Okay, guys, so we have about 1 minute left before it kicks us out. Like I said, look out for the next Zoom link on Blackboard. Um, so Dimitri asked me a question. If you didn't get your exam grade back, number 3, I have not finished grading. And number 4, we're going to take on Friday. But if you haven't gotten your second exam grade back, that's a little weird because I gave that back. I've returned that, I believe. So you can come to my office and take a look. I'm sure that it's in my office. Okay. Okay. So all right, guys, I'll post another link in about 10 minutes. Thank you.